Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore a new large language model called Zephyr 7B Beta. So Zephyr 7B Beta, it's a new release by Hugging Face H4. They also created a model earlier that was the alpha version of this particular model that was named Zephyr 7B Alpha. I do have a video on that as well. Please check that out. The video title is Zephyr 7B with Chainlit. Okay, so in that time we just inference the model in a chainlit application just to evaluate on some queries that how it's performing. Now in this video, we will use Zephyr 7B beta, but not for the standalone inference, but we are going to build a RAG system. So we are going to implement retrieval augmented generation using Zephyr 7B beta. Let's talk about Zephyr 7B beta. As you can see here I am currently on their Hugging Face repository. And I like Hugging Face H4, who are the creators of this particular model, because they have given some good open source large language models or the language models to the open source community. So one of their flagship is StarChat Beta. So they fine-tuned Star Coder and they created a new fine-tuned model StarChat Beta. So and they also earlier have created Google Flan Double XL, if I'm not wrong, which was a language model. So they are an expert in fine-tuning LLMs. There is no doubt about it. And now they have fine-tuned Mistral. And first they created alpha version of Zephyr 7 billion, and now they have Zephyr 7 billion beta. There are a couple of things that they have. I will talk because I don't want you to give you a lot of talks, and we in Hindi we call it Gyan, okay, which is available on their research paper. You can find it out on their repository. Here we will build a RAG implement. We'll do a RAG implementation. I'll try to test it out if it's working fine. On the retrieval augmented task. So if you look at here, they have used DPO, which is an acronym for direct performance optimization on the earlier model, and they have fixed like type sensitive or those kind of things, where earlier the responses were not that I'll say not that fancy when it comes to the writing English. Okay, when the model generates some keywords or the text in the words in the English language. So they have fixed all those things, and they have used DPO, which I assume is better, for fine tuning task in this particular model. If you come down, it has performed really well and surpassed all the other 7B model in the same category. That you can find it out over here. They have a radar chart for empty bench evaluation here. You can have a look on different categories like reasoning, how it performed in writing, humanities, and this green one is Zephyr 7B. You can look at the radius over here and how it has performed across all these categories. For performed really well. For humanities and STEM task. Writing again did not perform that well. For reasoning, which makes sense. LLMs struggles with reasoning or mathematics because most of them are not a knowledge model, okay, that can do a reasoning. Okay. Anyway, so you can look at over here how to inference the risk, because it's not RLHF or like human in the loop filtering or something like that. They haven't used it, so it can sometimes generate problematic responses if you do some prompt manipulation or something like that. So you can read it over here as well. Now they have the DPO config over here. You can have a look. They have the hyperparameters and all of those things that is available here. Now we are not going to use this model, of course, because the model that I'm going to use can run on a CPU machine. I make sure that. So we're going to again rely on the amazing Tom Jobbins, the block on the Hugging Face, and we're going to use one of his model that is called GGUF, which is unified format for inferencing an AI model on a commodity hardware. Earlier it was GGML, but now it's GGUF. So they have migrated from GGML to GGUF. Now it's a unified format for all these inferences on a commodity hardware like CPU machine or a single GPU. We're going to use this model through C transformers. C transformers is a Python binding for transformers in C and C++. Okay, so it has some capabilities that helps you inference LLMs faster on a CPU machine or a single GPU. So we're going to utilize this model through C transformers. You can again use this model through COBOL and OLAMA and etc. etc. You can again use Llama CPP and all to inference it as well. So I have downloaded a 5-bit quantized model this time just to be on the better side, because there is a myth. I don't know. I think that's a myth. When you compress these models, you might see a performance degradation. I do. Now I have seen those, but I still think that's a myth, by the way. So anyway, now let's jump into our. Let me just do a clear. Okay, clear, and you can look at, I have a folder here that's called Zephyr beta. Okay, let me open a VS Code thing, and if you look at the VS Code, these are the requirements that you need. If you want to implement a RAG on top of Zephyr 7 billion LLM, we're gonna use Chroma DB, which is an in-memory vector store. You can use some uh, vector store, or vector databases which are self-hosted, or it has a cloud version like Web8, Pinecone, Qdrant, etc. etc. Now here we're going to use Chroma DB. You can also use FAS if you want to do an in-memory vector store implementation. Sentence transformer for an embedding model. We're going to use Torch as a backend, C transformers as I explained earlier, Langchain as an orchestration framework, PyPDF as a PDF processing library, and Gradio probably, just to have a simple interface. If some of you wants to play, because the code will be available on GitHub, you can just download and run it as it is. Now, here you can see I have downloaded a 5-bit small quantized model, okay, KS. It's a 5-bit quantized. You can also use 4-bit quantized, but 5-bit will give you little better performances. Okay, and the configuration is, I have an i7 with 16 GB RAM and 1 TB SSD, the current machine that I am currently going to use. Now this is the document that we have. If you come here, it says pet care of a dog. Okay, where we have 20 pages in a document. You can have n number of documents, depends if you have what kind of vector database you use, that depends on that. Okay, if your infrastructure supports that, please go ahead and use n number of documents. You can use different vector stores. I have shown that in my previous videos, how to do a better RAG. You can watch how to have multiple vector stores, combine it together, and then do a RAG implementation. So this is what we're going to have here, right? This is a document, 20 pages. Looks good, that is why I've choose this document. This is about the dog's dog's care. Okay, so let's use that as a source document, and let's start writing some code now. The first file that I'm going to create is ingest.py. So let me just create this file where we will download an embedding model. We will write some code to create vectors, okay, out of the document, and then we'll store that in an in-memory vector store that we're using Chroma DB there. That's what we're going to do here in this case. Let's import OS first, and after that I'm going to use from langchain.textsplitter import recursive character text splitter. This is the text splitter that we're going to use that can, that can split on characters level. Okay, it also has character text splitter, but it's recursive character text splitter. It also has token text splitter, etc., etc. That you can also. This is mainly for the chunking strategy. How do you chunk your data? Now after that, we're gonna do from Langchain dot embeddings, and I'm gonna use BGE embeddings. I'm not going to use MPNet or mini LM by sentence transformers in this video. In most of my recent videos, I have used BGE embedding, which is by BGE AI Academy. So BAAI/BGE large in. That's the large embedding model on Hugging Face. See, I've been using so far that I now remember it completely. It's one of the best open source embedding model right now. I'm going to use the large version of that, and it is available in Hugging Face BGE embedding. It's not available in Hugging Face embeddings. It's available in this Hugging Face BGE embeddings class. Now, the module, by the way. Now, what else we need? So we need from Langchain dot vector stores. And I'm going to use here, let's use Chroma here in this case. I'm just going to write Chroma. It's not small c. I don't know why it's to Chroma. Okay. Now we also need a PDF loader. So let's do from Langchain document store. Document loader, by the way, so not document store. Document store is available in Haystack, if I'm not wrong. Okay, import let's do a PyPDF thingy here. So PyPDF loader. Okay, this looks nice. I think this is what we need, in this embedding thingy, guys. Okay, so now let's define the model name first. So I'm gonna call it model name. Let me just also define the other variables, model quarks, and it also has something called encode quarks as well. So encode quarks. Okay, now let's look for the model here. So let me show you. This is the model I'm going to use by BGE AI Academy. You can see it over here. One of the best open source embedding models right now. Okay, have around 70,000 downloads. Now let's come over here. Just use a string to save this. Like I'm going to store this, and then the model quarks. Now in the model quarks, I'm going to use CPU. If you have CUDA, you can also define that for a faster embeddings creation and storage. Now what I'm going to do here is device CPU. Okay, and then here in the quarks, it has a parameter that's called a normalize embeddings. If you want to normalize, I'll keep it false for this now. Okay, so let's use normalize embeddings, and normalize embeddings, and this embeddings is false. So let's do false, and then just let's initiate the embeddings over here. So in embeddings, and use the Hugging Face BGE class from that embeddings module from Langchain. And here I'm going to just do model name equals model name. That's what Python is, guys. Pretty much a readable programming language. Now you have model quarks, and then it goes model quarks, and then we have encode quarks, which is encode quarks. Excuse me. Okay, now this loads our embeddings model. Okay, now let me just do a print here. Okay, and say embeddings model loaded. Okay, now let's see if if are we able to just do Python ingest.py so far, and just see if we get that particular print. Okay, that we have printed embeddings model loaded. Okay, it will take a bit of time. If you are running it for the first time, it will take more time because it has to download the model weights and keep it in cache. Okay, but now I already have done it earlier because I just use the same VENV most of the time, so it's already in there. Okay, now this is done. So now let's have a loader. So loader equals PyPDF loader, and this is where I'm going to give the path name. You can also use directory loader if you have n number of files. I will recommend you using unstructured library. Works really good when you have unstructured data. That performs well. These are all trial and experimentation, guys. You have to try. There is no rule of thumb that that you can use. Okay. Now in PyPDF loader, let's do pet.pdf. And what I'm going to do next is we're going to load this. So documents equals loader dot load. And now here we're going to define our text splitter thing. So text splitter equals recursive character text splitter. I use tab9, by the way, the coding intelligence assistant, whatever you call it. Now here I'm going to do chunk size. I'll keep it a little bigger, 1000 for now, and chunk overlap as 100. Again, it's really intuitive, no thumb rule that you have to keep 1000. Okay, it's always trial and experiment, and it depends how have you basically how you extract the data from your source document. So it depends on those things. Now text splitter is done. Now let's have a text, and in text I'm going to write text splitter dot split. I'm going to split that. I'm just going to pass the documents. Not split documents. Yeah, and I'm going to pass the documents. Okay, now this text right now, let's just do a text and just to print this. Okay, let me just show you. So print here and text and 0. Okay, now what I'm going to do here is, let me just show you, Python ingest.py. Okay, Python ingest.py, and we will get the first of the list. Okay, once you can see it over here, we got a page content, guys. It says dogs are hugely popular pets, and they are, by the way. If you are the dog lovers like me, in fact, there are 8.5 million dogs being kept as pets in the UK, in the United Kingdom alone. That's a huge number, by the way. Okay, now this text has been done. Let's just remove this. And now what I'm going to do is I'm going to have a vector store initiation here. So excuse me, vector store variable. I'm going to call it chroma.from documents. If you have to create vector stores, if you want to persist it or save it, then you have to first do from documents, and you can save it, and then once you load, you just have to do chroma. So let's see that. So from documents, and here I'm just going to pass text. That's the first thing we have. Then the embeddings model, so which variable is embeddings. And then now I also want to define a collection metadata. I have explained that previously in many of my videos, that how you can define the config, how you can create a configuration for your collection metadata that you are going to collect. Okay. Now it's a key value pair, it's a dictionary. So here, now what we're going to do is HNSW and space, and this here. Now you can define what kind of algorithms you want to use. So it supports dot, it supports cosine, it supports L2, different other algorithms that you can define. So here I'm just going to call it cosine for now. Okay, now this is done. Now here you can also do persist directory if you want to save that inside. This will be a volume that will just store it somewhere, and I'm going to call it stores, and here stores, and let's call it pet cosine. That's it, guys. That we are done here. Okay, so what we are doing here, if you look at this vector store, we are passing the text that holds all the extracted text. It has the embeddings model that we're going to use. This is the embedding model, and here we have a collection of metadata where we're going to use cosine when this entire embedding will be stored in an n-dimensional space or within Chroma DB. Okay, and then we have persist directory where we are persisting on the local disk. Okay, stores pet cosine, something like that. Okay, now let's just do print vector, or probably I will not do this because I'm not going to create this vector store because I already have stores here. If you look at over here, I already have created stores for pet cosine, the same name, and this is how the structure looks like. So if you are facing any trouble, please comment and I'll be happy to help you there. Now these are the file. This is how the file looks like after a successful embedding creation. Now what you have to do in that case, you have to come here and just have to do Python ingest.py, and it will create the embedding for you. It will take probably a minute depending on how big the document or how many documents you have. This is how you create an embedding, guys, using BGE and Langchain. So now let's save this, minimize this, create a file here called app.py. Now in this app.py, guys, we have to write all of our code logic. So the first thing that I'm going to do is from Langchain import prompt template, or rather let me just do it. Okay, so from Langchain import prompt prompt template, and I'm also going to need, I don't need LLM chain. Okay, so from Langchain import prompt template. Okay, now from Langchain.llms, and here I'm going to use C transformers. So you can also use C transformers through Langchain. You can also use C transformer standalone. You can just use from auto causal LM dot from pre-trained. You can also do that way as well. Now, I prefer using, if I am using Langchain, I will use Langchain. Okay, otherwise I will not use Langchain. So from Langchain.llms import C transformers. I like C transformer. Thanks to Marella, who is the creator of this wonderful library. Now import OS, and okay, we need again the vector. We need the vector stores, guys. So import Chroma. That's the problem with Chroma. I don't know why it's okay. Now we need a chain, a retrieval chain. So let's do that from Langchain.chain. Sorry, I don't know what I was writing. Import retrieval QA. This is fine. Let's get the BGE embeddings again. Embeddings, import Hugging Face BGE embeddings. Let's import a Gradio here as GR, and let's import, what else do we need? For now, I think we don't need anything. Now here we're going to define our local LLM path. Make sure that you have downloaded this kind of model, a GGUF model. Okay, so now Zephyr, and you can see I've just pasted over there. Let's define a config. Okay, I'll copy it quickly from my GitHub, guys. So let me just go on my GitHub and get it. I don't know why it's so slow, but anyway, I'll take it from to this repository. Why to write the same code again and again? Maybe I can explain that. I just need this part of the code here. Okay, now let's do that. Now what I'm doing here, let me just show you. I have a config variable that stores this maximum new tokens, repetition penalty, all these inference parameters. They are not hyperparameters, by the way. They are inference parameters because you are going to use this in inferencing the LLMs. Now here we have a temperature. Let's minimize the temperature because for RAG, I always recommend minimizing the temperature. If you are doing an information retrieval on your knowledge base, to keep a check on a bit of on the hallucination. It directly does not like impact the hallucination directly, but it has some roles to play. When it tries to become creative, it generates a lot of randomness or random responses, which might be hallucination. Now you have top P stream, and yeah, threads or something like that. Okay, this is for adjust for your CPU, how many threads you have and something like that. Okay, now here I'm using AVX2 because I want to just make it faster inference, and you will see that how fast it is. Probably takes around 40 seconds on CPU, and I'm not also going to stream the responses. If you also stream the responses like through Gradio altogether, because C transformers provides that, by the way, you can also do that. It will be really faster. In 20 seconds, we will start seeing some results. Now, we are here. We are okay with this, guys. Let me just close the charge. Okay. Yeah, LLM is done. Now let's have a prompt template. Okay, so here I'm going to define a prompt thingy. Okay, so let's just again go back to my GitHub. Why to write the code? I'll go to my Llama 2 medical chatbot. One of the most viewed video of mine, okay, on my channel. Thank you so much for all of you, or to all of you. Now here I'm going to use model.py, and I'm just going to copy this custom prompt template. Let's copy that, come back here, a very simple prompt. Let's call it prompt template. It says use the following pieces of information, and you can do a lot of creativity here on these prompting techniques. You can do a role-based prompting, an instruction-based prompting, a chain of thoughts, etc., etc. I'll keep it simple here. Now I have context, I have question. This looks nice. This looks nice. Now let's come down. Let's bring up the models again. We still need this to pass as an embedding function, because once you ask a query, you need the respective vectors for that as well, right? That's why we're going to use that here. Now this is also done. Now what I'm going to do here, I'm going to call it, okay, prompt template, and inside this prompt template I'm going to pass template, and template equals prompt template, the variable, and then I'm going to pass my input variables. So input variables, and input variables text list. So in this I'm going to pass context. So let's do context, and then after that I'm going to pass question, that is question. We are done with this also. Let me make it like this. Now prompt is done. After prompt, let's do a loading the vector store. Now we're going to load the vector store. We already have persisted in memory, right? Now load vector store, and here I'm going to write Chroma and then persist directory. So just do a persist directory, from which directory you want to load that. Okay, so I'm just going to call it stores, and here I have pet cosine. I don't know why this is becoming capital. Okay, pet cosine, and then we're going to have embedding function, and this embedding function is going to be my embeddings. Okay, this is how you now load. So now you don't have to basically do it in every runtime. You have saved your vectors in memory on disk, and now you just load it. That's it. Now here let's have a retriever. Oh, retriever, and your retriever is load vector store dot as retriever. Okay, so as retriever. So this is amazing. I don't know why I'm not getting that dot as retriever. Okay, as retriever, it becomes a function, and here I'm going to write search quarks. You can pass how many document you want to search within. Okay, like you want to retrieve, not the search within, how many you want to retrieve, as a retrieve chunk, so you can pass it to a large language model for generation part. Now here I'm going to just do k equals to 1. I would like to keep it short. Okay, search k equals to. Now let's do a query here first, and in this query I'm going to say what is the fastest. Let's ask that question. Okay, whew. I had a question that I really liked it. I wanted to test on some complex questions. Where did it go, man? Yeah, this one. The fastest recorded speed of a greyhound dog was 42 miles per hour. Now I'm going to ask this question because it also has numbers, and let's see if in GIF, if first the retriever and then the Zephyr, if it's able to retrieve or not. The BGE embeddings through. Whew. Okay, this is going to be this. Okay, now and not equal. I don't know why I did equal. It's colon. It's a key value pair. Okay, search quarks. Now, what is the fastest? What are the question? What is the fastest greyhound dog? Okay, what is the fastest speed for a greyhound dog? Now here, let's do a semantic search first on the retriever. Let's first retrieve and see if it's able to retrieve the right set of chunks. And I'm gonna say retrieve. I don't know why I'm feeling that retriever spelling is wrong here that I have typed. Okay, retriever. Okay. Now retriever dot, it has a method called get relevant. Okay, get relevant documents. So it has this method that we can use, and we just pass our query. So let's pass the query here and then just do print semantic search. Let's see if it's able to retrieve this. Okay, now let's run this guys here. Python app.py. Okay, let's see that if it's able to able to retrieve the right set of chunks and all. Okay, if your retriever is working fine, right, that's the first important or critical thing. And you can see I got my response. Okay, I have k equals to 1, so I got one page content, one document. It says dogs are hugely popular, something like that, and it is not able to retrieve, I think, the answer there, which is really surprising. What I will do now is what if I make this k equals to 2 at least and see if it's able to now retrieve. Let's see that. Greyhound dog. And you can also set up some threshold values. Okay, now you saw that I didn't get that 42s anywhere. Okay, in this thing. Now, yeah, you can see it over here. Yeah, this is the right result. Okay, fine. And I think I did a mistake. I think it was there also, right? Let me see that. Why I can't see, my eyes are like gone. Okay, because it's the same response. Yeah, you can see it over here, 42 miles per hour. Okay, so let's keep it as 1 as well. I was not attentive. Excuse me for that. Now we are okay to do the print semantic search and all, guys. Now what we're gonna do next is let's here divide a print thingy, and here we're gonna write our logic. So let's first create a for prompt. Let's call it chain type quarks, and here chain type quarks, and this is again a key value pair, so our prompt gonna be prompt. Prompt. And now let's create a QA chain. So let's call it QA, and I'm going to use retrieval QA dot from chain type. Okay, from chain type, and let's use here LLM equals LLM, and let me just go up so you can see it. Chain type equals stuff. You can also use re-rank, refine, map re-rank, etc. Depends what kind of use cases you are working on. If it's a summarization, use the refine. That depends what kind of use case you are dealing with. Now retriever equals retriever, and return source document. So return underscore source documents equals true, and then we have chain type quarks equals chain type quarks, and you can also do verbose equals to true. Verbose equals to true. This is now we have a QA chain. This is our RAG chain now. Okay, which uses retrieval QA because we are not looking at the conversational part of it. So it has a retrieval QA from chain type. It has an LLM. It has a chain type stuff. It has a retriever thingy. It has a return source documents. Blah blah blah. Right now, what I'm gonna do here is let's have a response variable, and I'm gonna call my query on top of it. So QA query, and I'm going to just uh, uh, run it now. Let's just do a print response and see if it's working. If you're getting the right response, the question that we ask using Zephyr. The whole agenda of this video, guys, is that when I use Zephyr alpha model, it was not that good for RAG. I will be honest. And I love Hugging Face H4, by the way. I'm a huge fan of the creators of this particular LLM, when they fine-tuned this on Mistral. Alpha model was not that good for RAG implementation, but when I tried beta one, it was really working fine, and that's why I wanted to create a video for all of you. So if you are looking at some replacement of Llama 2 or Mistral, you can look at Zephyr, the beta version of it, and that's why it's a beta version, right? Now let's do a print response and see. Now here what I'm going to do is let's just run this again, python app.py, and it will take a bit of time now because it has first it will retrieve the retriever, and then LLM is going to read those and then form a human-like response for you. It says LLM is not defined. Oh, okay. Okay. We have not LLM. We have let's call it LLM. Okay. Fine. Ooh. These are the mistakes. If I keep on making this kind of mistake, how will I become a YouTuber, guys? Then probably I have to do a lot of edits. Stop the video, edit, again merge it, create. No, but coding is fun. If you do coding live, then it's much better, to be honest, in my views. And that's why a few of my videos are a little longer, but I want to create those videos where I want you to write codes alongside me, with me. When I'm writing code in video, you're also writing your machine. Okay. Okay, now of course I do have my notes and all, for some kind of explanation wherever it required, the pointers and all. Okay, you can see it has entered into new retrieval QA chain, and probably it takes around 30 to 40 seconds for generating that response based on the retrieved chunks. Based on the retrieved chunks that you see, the chunks had been retrieved over here. You can see the 42 miles per hour, and meanwhile it's doing. Let's write the Gradio code to save some time. Okay, so what I'm going to do is first I'm going to do a sample prompt here. So let's define a sample prompts, and it's going to be a list. The first one I will just keep it again this. So let's keep this here, the first one, and I'll just do an Alt G here. So now the next one is why should we not feed chocolates? Now suppose this is the question that I'm asking to the dogs. Okay, now the third question that I can ask is name 2 factors which are important for the dog's care. Okay, now suppose this is the third question. Now this is the sample prompts. I'm going to build a very fast Gradio application. Now I'm going to write a function here, define get response. Function that we can use it, so we don't have to generate. Here we're going to pass an input. Input is going to be prompt. So let's query is going to be input. Excuse me, sorry. Query is going to be input. Let's have a chain type quarks here again. Chain type quarks prompt. to this is going to be inside a function, and maybe I can just use this entire thing here, QA thingy. So let's just bring it here. Ooh. Oh. Ooh. Verbose and all, we can keep it true. And now let's have let's see that, if we got our response, guys. I don't know what I did. We got our response. Fantastic. You can see the result by Zephyr 7B beta. It says the fastest recorded speed for a greyhound dog is 42 miles per hour, which is the right answer, which is fantastic. And this is a complex question, trust me when I say it, because it has some numbers, dates involved or whatever. It has some numbers and numeric thing where LLM struggles, and it is a part of that PDF as well, as you saw, right? Now you can improve the prompt to keep the model stick with the embeddings, the knowledge base, not to its base knowledge. You can do that. Now here, what I'm going to do next is, let's do a response thingy again here. So response equals QA query, and then just return the response. So let's just do return response. I'm not going to do any output parsing. Maybe you can do that as an exercise if you want to do. Now this is done. Let's create a variable called iFace for the interface, the Gradio interface. And what I'm going to do is gr dot, but it's not showing, interface. Yeah. And here I'm going to define a lot of things. The first is inputs. So input is going to be my input. So let's do that, because that's what the function is. And then we have to define the input, because we haven't defined the input yet. So let's define an input first. So what I'm going to do here, input equals, we're going to have a text box. So let's call it text. And inside this text, I'm going to write my label. So label is going to be prompt. Oh, phew. Prompt. This is going to be your prompt. And then so label. Let's keep it so label. Let's keep it false. And then we're going to have maximum lines. Let's keep it, probably let's keep it 1 for now. Okay, maximum lines. Then we're going to have placeholder. And placeholder is going to be like enter your query or something like that. Okay. And then we have a container equals false. I don't want it in the middle of it. So container equals false. Now this is going to be my input, a single text box where we're going to put our questions. Okay. I put it outside. Sorry. Now here, let's have an output then. So we're going to have an out. We forgot to do one thing, guys. Where is the function? This is really strange, because I need a function. So the function is going to be the get response here. So get underscore response. Let's make it structured. Okay, now the function is done, which is a callable function. That's what Gradio application will call, right? Now after that, I'm going to have an outputs. So outputs equals, here I'm going to have text, and after that, outputs text is done, title, and title, let's call it my dog pet care rag implementation using Zephyr 7B beta. Let's remove my thingy, or let's remove my here. Okay, I removed the my thing, and now after title, let's have a description if you want. I'll say rag demo for Zephyr 7B beta LLM. Okay, now this is description. After description, what we're going to do is we're going to have examples, and here we're going to pass our sample prompts, guys. Okay, so we have sample prompts. See the examples which will be in the below. I will show that. And now let's have a couple of, let's say flagging equals false. If you want to do flagging and all, you can keep some logs. Also a screenshot. Let's disable screenshot if possible. Screenshot equals false. True. Okay. Now this is done. So just let's do iFace.launch. Okay, so we are done with our code. Let me just explain what we are doing here quickly. So you would have seen this earlier, like when I ran it before writing this Gradio. Let's just we don't need these now. Okay, at least let's just okay, let's just do a control. Excuse me. Control hash. I just hash those because I don't need it. We also don't need these 2 lines. Oh, these 3 lines, by the way. So let's just do a control hash. I don't know why I'm again typing the wrong button. Okay. Oh, we also don't need. Oh, maybe let's also hide this. Okay. We don't need those things. And then we have sample prompts. We have our keyword thing going on. I don't know why this is giving a. Excuse me. But it's giving a bad feeling. Yeah, the indentation was wrong. Whew. This is the problem. Okay. Then you have a response and then you have the response. I hope this is okay. Okay, this looks nice now. Okay, so now we have this all okay. Let's run this now, guys. Okay, so Python app.py. And let's copy this probably. I think I would be running it on 7860, right? Let's see that. 7860. I'm not running it. So I haven't run it Gradio yet. And now once I hit enter here, you can see a simple, very bad looking interface where you can type some question. Let's ask the same question first. And you can see this is a question here. What is the fastest speed for a greyhound dog? Okay. And these are the example prompts. You can put multiple examples. You can do redo, undo, a lot of other customization with Gradio you can do. Probably. And here we are using a Zephyr model for RAG implementation, guys. I am focusing on that because it performs good. So here we are not parsing any output. We only have the complete output, the raw output that we're going to present. Okay. As I said, right, it takes around 40 seconds at average. Probably, I don't know why it's taking, let's see how much time it takes for this one. Okay, and it's running on a CPU machine. We are not utilizing any CUDA here. You can see it has entered into the QA chain and it's working. It's generating the response for you. Okay. And just to tell you that this entire code will be available on the GitHub repository, guys. So you can just go and fork it or just download it and try it out yourself. And you can tell us the entire subscribers or people who are going to watch this video, you're finding, you can comment in the comment box as well. Oh, it took more than a minute. This is surprising because it was really fast when we were doing it in terminal. Let me just go back to code. iFace launch, iFace. We have this get response function defined, which takes an input, which is query, QA query. This is fine. Okay. Callable function inputs equals input and okay, prompt equals prompt. Let's see. This is so surprising. I don't know why it's taking that much of time in the Gradio application. But anyway, we'll wait for it. Or are we? It took 2 minutes. Input Gradio. New. This looks good. Function get response inputs input text title sample prompt iFace.launch. Okay, anyway, let's see how much time it takes. Oh, it took, I don't know, it took it took around almost 2.5 minutes for this response, but in terminal it was really fast. Probably we have to check that out, that why it's taking, at least it will definitely not take 2 minutes, in terminal, if you use time to calculate it. So you can see the question here, what is the fastest speed for a greyhound dog? And we got our result. The fastest recorded speed for a greyhound dog was 42 miles per hour. It gives you the source documents, the page content, and the PDF as well, that from which PDF you have. You can pass the output in a beautified format. Now, this is what I wanted to show you guys in this video. Now you have a skeleton. You can just take my code and work it, make it better. run it on a CUDA machine. How do you run this on CUDA machine? It's very easy. When you are using C transformer, you have to pass the number of GPU layers and make sure that you have Cubeless and Metal or whatever that you are working with. You have those supports depending on which operating system you are on, guys. Most of the time, you will say that GPU layers, n number of GPU layers are not working for C transformer. There are reasons for it. You might not have the support for that operating system probably. Maybe you should check it out. If you have the Cubeless support, if you are using it, if you have a blast, because these are softwares that you need the support to inference it. So that's all. I'll give the code, GitHub repository in the description. If you like the video, please hit a like icon. If you have any thoughts, feedbacks for me, please let me know in the comment box. You can also reach out to me through my social media channels. And if you haven't subscribed the channel yet, please do subscribe the channel and support the channel, guys. That's what motivates me. That's all for today's video, guys. Thank you so much for watching. See you in the next one.